My name is Colin Graham. I work in the Technical Advisory Unit within Invest Northern Ireland. So I would like to welcome everyone to our CE Marking Electrical webinar this morning. This is the first in a series of 3 half-day webinars, which Invest Northern Ireland is hosting today, next Thursday, the 20th of November, and the following Thursday, the 27th. So next week, we're going to focus on CE marking for the machinery and mechanical engineering sectors. And the week after that is the Global Technical Compliance event, where we will look at compliance requirements in the major global markets beyond the European Union. Some of you will probably know we've been running these events for quite a number of years now. And since moving over to a webinar format a few years ago, we're happy to be able to continue to offer the webinar free of charge, which we hope is helpful. And certainly interest has been very strong for this year's webinar series. We're pleased, in fact, to have over 70 people registered to attend the webinar this morning. And we have people registered from a very wide range of companies all over Northern Ireland and indeed beyond these shores in India and Canada and England. So welcome to everyone this morning. As I mentioned, this is a half-day webinar and we'll have a break around about 11 a.m. We're also going to do regular question roundups throughout the morning. So we'll finish off around about 1 o'clock. But if you have any questions at any point as we go through the material this morning, please enter your question in the question panel at the side of the screen. And our colleague Barry from Eventful will gather those together and we'll try to provide answers to everyone at the end of each session. The number one question I guess we always get is, will we get the slides and will we get a recording of the webinar? And the answer is yes. We will make the presentation available as soon as we can after today. So please keep an eye out for that in your email and in the days to come when we've had a chance to get that together. So our presenter today is Simon Barracliff. Simon works with Element Materials Technology. Simon's a chartered electrical engineer with over 35 years of experience in product testing, assessment and certification. Currently, Simon works as a senior technical specialist at Element, including coordination with Element's EU notified bodies. Simon has very extensive global technical compliance experience, and he has worked with many companies, both in Northern Ireland and right across the world over the last 25, 35 years. So we're really pleased to welcome Simon back to lead this morning's webinar. And let's get things started now, and I'll hand you over to Simon to get us underway.
All right, thank you, Colin. Thank you for the introduction. Yes, as we were saying earlier, this is the 25th year we've been running this with Invest Northern Ireland. So quite a long association with that. So welcome everybody. We're going to go through a wide variety of topics today. So look forward to those questions on the chat, and Barry will prepare those and we'll deal with those when we get to the Q&A session. So please don't be shy with those questions. As Colin said, I work for Element Materials Technology. We're a global test inspection and certification company. 8,000 colleagues in over 30 countries, a whole wide range of product areas, materials testing, aerospace, automotive, construction products, whole area, as well as the area we're concentrating on today, which is sort of electrotechnical equipment, and specifically CE, and a little bit on UK CA marking and how that interrelates. In terms of our service offering, I'll leave this slide on the deck so you can see what we do. But it's not just testing of products, it's advice, it's certification, it's global market access, a whole range of directives, regulations for the EU and the UK, but also for that global marketplace. And we will be looking at global marketplace in a separate presentation for Invest Northern Ireland in 2 weeks' time. So we'll cover that at that point. So advert over, onto the topic that you're here to listen to today. This is UKCA and CE marking. Now we've grouped these two things together because of the similarities. It's just trying to put the terminology into context. So from a UKCA perspective, which is for Great Britain, it's UK regulations and statutory instruments. We have, those are based upon designated standards, which the Department of Business and Trade cover. We have UK approved bodies who are third parties appointed to oversee some of the directives. And then we have a UK declaration of conformity, albeit that only covers Great Britain. That contrasts with CE, which is the more broader topic, and again relevant to you in the north of Ireland, which are EU directives and regulations, and those read across very, very largely from the UK regulations, or the UK regulations copy the EU directives and regulations. EU have harmonised standards, same thing as designated, notified bodies as opposed to approved bodies, and an EU declaration of conformity. Because the UKCA system is spun off the CE system, it's just differences in terminology. There's very little practical differences. It's just where it's going to apply. So as I said, it's Great Britain for UKCA, north of Ireland is CE, UKCA does not apply. And UKCA doesn't apply in the Crown dependencies or in British overseas territories. What's also important to note, though, is that whilst UKCA would seem like a brilliant idea, in practice it's incredibly burdensome for industry, both within the United Kingdom and in the EU. So recent changes means that effectively CE marking is seen as an acceptable alternative to the UKCA marking, and so we've gone back to where we were pre-UKCA, really, where CE mark is good for all markets, which seems like a more sensible approach. Some customers still want to use UK CA for specific reasons. Sometimes it's written into contracts, but predominantly CE marking is the way that we're going. So the effective use of CE marking is shown on the plot there, which is 28 that follow that. So I think it's worth looking at this in the context of CE, and just accepting that there is some read across to UKCA for those that need it. So let's have a look at the EU compliance framework, the thing that underpins CE marking, and we're going back a very long way, back into sort of into the 90s. For CE, and prior to that, to when the UK first joined the EU back in 1972-73. Goods and services, because they're traded freely within the European Union and within the CE marking area, there needs to be common requirements so that regardless of the country, you can recognise that the compliance requirements for your particular area have been covered. And so in 1985, the European Commission created a process called the New Approach, and that was about harmonising not just individual directives and regulations, but creating a framework that tied them all together. So when you were CE marking, if you were applying 1, 2, 3 or more or directives or regulations, you followed broadly the same pattern for each one. And that developed over the years. We got a lot of CE marking directives launched in the 90s. And in 2008, the Commission did a little review and introduced something called the New Legislative Framework, the reference there. And this tied the regulations together, not just for what the requirements on the product, but also requirements for market surveillance, or how governments dealt with CE marking. So it really tied it together and set the scene for the development of the newer sets of directives and regulations for European products. And once that was introduced in 2008, all of the directives and regulations were reviewed and adapted so that they were compatible with the new legislative framework. Now, that's the framework. Why is it important to talk about it for now? Because we'll cover that a bit later on in this presentation. So EU directives and regulations. Now, this isn't an exhaustive list. It's some of the more common regulations that people need to apply. So batteries are missing off this list, but we're one of the most common. But it is, and of course, the machinery directive at the moment applies to machinery equipment. So that's going to become the machinery regulations coming in 2027. So these directives exist, but they're fluid. They are changing. Many of them, like medical devices, are becoming regulations rather than directives, so that to make it easier for people to apply. And really, the difference between a directive and a regulation is a directive has to be implemented specifically in national legislation, and so you can get minor differences. Whereas a regulation is EU-wide from when the EU publish it. It doesn't require the same level of national endorsement. So there's more harmonization in a regulation, like medical devices, as will be for machinery, than for directives. And the direction of travel is towards these regulations, with the rules being set in Brussels and everybody having to follow them automatically. What that means is when a regulation is published, it applies everywhere all at the same time, and there isn't a sort of drag of 3, 4, 5 years while individual countries implement it. But in terms of what they mean and how they affect CE marking, largely the regulation directive for a manufacturer mean the same thing. So within the new legislative framework and how it describes the directive regulations are set up, it broadly specifies 3 pillars of compliance, which are standards, which is testing and assessment to prove compliance. How do you know your product meets the CE marking requirements? Generally, some form of test and assessment needs to be done. So there's a role of standards in that. And the European Commission mandates the use of standards to support the various directives and regulations. That system has been active for many years. There's a slight issue with it in that because the European Commission has concerns over being sued because a standard could be wrong, they have been reviewing and revising the standards that are being published under their own mandate by the European standards bodies, CEN and CENELEC, making changes, making recommendations, to the point that that system has ground to a halt, because industry is writing standards and the Commission are not accepting. So there's something called the Official Journal, which lists standards that you can use with your for CE marking purposes and are recognised to provide a full presumption of conformity. In other words, the standard's fully compatible with the directive or regulation, but they've stopped publishing those because of the problems with the standardisation process. So we can see when we get to the new legislative framework, possibly a change there in the way we recognise harmonised standards going forward. But for the moment, harmonised standards as per the Official Journal, but you can also use standards published by CEN and CENELEC for most of the directives and regulations before they are listed in the Official Journal, which means you can maintain state of the art. So standards is the first pillar, really important part of the scheme. The second is the evidence pack. So you have standards that provide you with the technical guidance, and then within each directive and regulation, there are other things you need to do on top of what's in the standard. That could be specific sets of marking, it could be specific types of risk assessment, specific types of documentation you must file or present to the customer or have available for market surveillance. So there's documentation requirements, and for all of the directives and regulations, the manufacturer must compile this evidence pack according to the rules of the individual directive or regulation, and retain that pack normally for at least 10 years after the last of those products is made, and made that pack available for inspection by customs, health and safety people, and other government regulations. So that's the second pillar. And we'll talk a bit about documentation as we go through the various directives and regulations today. The third pillar is production, and this is quality processes, the system for ongoing compliance. So you've compiled your evidence pack based upon what the requirements of harmonized standards have said, and then you've made a product, but every product needs to conform to the type described in that technical documentation. And to do that, you need some sort of production QA process to do that. Normally, that's going to be something as simple as an ISO 9001 based system, but for some of the more high-risk regulations and directives like medical devices, explosive atmospheres, there's mandatory production control processes using specific production control standards that are sort of ISO 9001 plus. Now, we're not going to touch any more on that, so that's why that's highlighted in red. It is there, it's part of the CE process. It varies from directive, and regulation. So when you're looking at your particular CE marking directives or regulations they apply to you, you do need to apply that. But for the purposes of today, we're not going to talk about that in any great detail. So what does CE mean? Well, it's the mark on a product, and it's you as the manufacturer's self-declaration that the product placed on the EU market complies with all relevant essential requirements of the EU directives or regulations. The essential requirements are the rules applicable to that directive, listed in the back of the directive or regulation, that say you will have met certain minimum criteria. Now, these are not the same as what's written in standards. They are the minimum criteria that the law requires you to do. So there's a difference between complying with the standard and complying with the directive or regulation. When you CE mark, you comply with the directive or regulation. The standard is just the tool to demonstrate compliance. So it's the essential requirements are key to this. So regardless of whether you need a third party, a notified body for CE marking, it is the manufacturer's sole responsibility to put that mark on the product. And the CE mark must be affixed before the equipment is placed on the market or put into service for the first time in the EU. So it's your declaration as the manufacturer that all of the relevant CE marking regulations have been applied, and that you have the technical documentation to support that, and you've detailed that with declaration of conformity. But the CE mark's not a mark of quality of safety. It's just a mark for trading purposes. It's just a visible demonstration on a product that you have read the regulations and applied them as far as possible. It doesn't mean that you have applied them properly. It just means that you believe that you have. So CE is not a guarantee of anything really, but at least indicates that if questions were asked about the product, then documentation should be available to support that. So in the old days, CE, what does it mean? Conformity European, but actually caveat emptor, that the buyer beware, because the buyer has really no way of knowing whether the whole process of testing and assessment and documentation has been carried out. Because the only people who can ask to see that documentation by law are those enforcement agencies and customs people. So the CE has meaning, but you just need to be clear what the limitations on that are. I've talked a bit about notified bodies. Now, for some directives where the product risks are high, so like potentially explosive atmospheres, some dangerous machinery, medical devices, or where there's no standards available for that particular product, then you're not allowed just to stick the CE mark on without consulting an external expert. So effectively, self-declaration is not permitted, although you're still responsible for the CE mark. And the EU has then designated technical experts under the specific sets of directives and regulations, which conform with very, very clearly defined rules to demonstrate their expertise. And these bodies are called notified bodies. And the regulations or directive will say when you must use one of these bodies. So for machinery safety, there's a list in Annex 4 in the Machinery Directive, really dangerous machines where you have to use a third party to produce the test report and issue you a certificate before you can sell the product. For medical devices, that the medical device regulation, you need to have the technical file reviewed by a notified body, and in many cases the factory is inspected by. For ATEX, explosive atmospheres, again, testing by a notified body, by an approved third party, and your factory production control monitored also by a notified body. So notified bodies exist, but only for certain directives. Majority of directives we're going to talk about today, so low voltage directive, EMC directive, radio equipment directive, it's self-declaration by the manufacturer, no notified bodies involved, but you just need to be aware of their existence. So regardless of whether it's EU or UK legislation, we've got mandatory rules for compliance, which are the regulations of directives, and then non-mandatory rules, which are the harmonized standards. So the standards themselves are not listed in the regulations or the directive. What the regulations and directives do and say, if you want to know how to meet the requirements of this directive or regulation and have a presumption of conformity, then here's a set of standards you can choose to apply. But it's not mandatory to use those standards. Having said that, if the standard exists for your product and you choose not to do it, then you're going to have to describe that in your technical file and explain why you chose not to. Why do you know better than the collective knowledge of industry who wrote the standard and the European Commission who nominated that standard? So in practice, harmonized standards tend to be the route that people follow because it's the safest and the easiest. That all goes into your technical documentation. So all of these directives require the manufacturer to establish technical documentation that needs to be approved by the notified body or not. What that documentation should include is an adequate analysis and assessment of the risks. So it's not a matter of just saying, oh, let's just grab a standard and test it. You need to look at your particular product and decide what risks in the terms of that directive or regulation exist. It needs to include a general description of the product so that enforcement agencies or customs agencies, when they ask for the file, can see that your file actually applies to the product they have in hand. It needs necessary conceptual design and manufacturing drawings, schemes of components, bill of materials, descriptions and explanations necessary for their understanding. So it's not a matter of just saying, yes, my product complies. You need to describe the product in technical detail within this file. You list harmonized standards or other technical specifications that you've applied to meet those essential requirements. So a lot of the harmonized standards have lists of essential requirements in that. So you can see which ones you meet by applying the standard. Not all standards cover all essential requirements. So you need to think about the essential requirements list and put that. If you've done testing, which you will in most cases, you need to put the test reports, results of your examinations and tests in the file. And then when you've done all of those things, you compile your declaration of conformity. And there are very, very specific rules for what goes into that. And we'll cover that a little bit later on. And then last but not least, measures to ensure ongoing conformity. So that's that third pillar. What are you going to do in order to ensure that the products you make conform to type? And also, no product stays the same once it's been manufactured. What do you do when you make the next one, and so on and so forth? what's your processes for updating and changing the file, and approving the continued use of the CE mark. So the EU Declaration of Conformity is signed by someone within the manufacturer to say that they've met all those requirements, and that signature effectively is the internal authorization to apply the CE mark. So let's go back to the top of that list and look at this adequate analysis and assessment of risks. What does that mean? Well, what's the approach to risk? What hazards are there and how are you going to deal with them? So, you could just close your eyes. You could just assume if I don't look too hard, then the hazard isn't there. And as in my animal example here, that isn't going to get you very far. So you need to think about what criteria you might need to apply. So if it's a radio product with more than one transmitter, when I'm doing my test and assessment, do I test with all the transmitters on, just one on? What's the worst case? What's the most practical case? How have I considered all those operating modes? So when you're testing equipment and assessing it, have I considered all the modes that I'm permitting the user to apply? But also, you have to take into account a reasonable and foreseeable misuse as well. So how might the end user use this? And what's the risk if they do use it in a silly way? If you've got radio products or EMC, do I buy in pre-approved parts or pre-approved components, power supplies that have already been tested and certified? Do I need to retest them? Full probably, but I do need to look at how they figure into my end application. That's really, really important. So I do need to consider even pre-approved modules. So even if it's CE marked already, just because it's CE marked doesn't mean you can just use it. There is an element of risk about combining CE marked components in your particular application. And even for simple products, battery powered products, for example, are there really no product safety risks? The lithium batteries are extremely dangerous. So things like e-cigarettes, an e-cigarette itself got a tiny battery in it, but when it's being charged, they're a major risk of fire. So you need to look at all the risks associated with the product. Don't assume for product safety it has to have, meshing gears and sharp blades or be mains powered to be dangerous. And then how do we know it meets the essential requirements? So this is about looking at those essential requirements in the directives and regulations and making sure you meet those. And the essential requirements are much broader than the standards. They're general principles largely, and they're there to guide you for what you need to think about. If you then pick up a harmonized standard, that'll give you some more detail and some more ideas of what the risks are, what the hazards are, and what the mitigations are. But particularly for innovative product, the standards may not have considered your particular situation. So there may be hazards and risks to compliance with that directive or regulation that aren't envisaged in that standard. But you still have an obligation, because you're meeting essential requirements and not standards before you CE mark, to address all of those requirements. You have to keep the wolf from the door. So the risk assessment cycle: you identify, you analyze, you action, you monitor, you control, and then you go back around the loop again. So risk assessment's an ongoing process, so it ties into that technical documentation process as well, the process of continued conformity. What are the risks? Have I identified them all? And you may identify risks as you go through with experience with the product, in which case you do need to you need to follow those through. So the risk assessment really is the first document you open. It's the last document you close. And then once you've completed the process and you said done, CE mark, finished, it's part of your monitoring program, and hence it is the place that you start again on that. So, declaration of conformity. Similar to all of the directives and regulations, you need to specify the product by batch, serial number, and clearly identify it. Name and address of the manufacturer or authorized representative. You need to make a declaration. It's issued under the sole responsibility of the manufacturer. Clearly describe what it covers by model and type. What legislation you apply. And the declaration of conformity needs to list all applicable EU regulations and directives. And you have an obligation to apply all of those before you can CE mark. If you've used standards, then you list those on the DFC as well. Any other additional information that might come out of the directive or regulation, and then a signature for on behalf of the company. So it's not you signing as an individual. If you're an employee, you are signing on behalf of your organization. So who are you? What's your job function? And a signature. So someone who's taking responsibility and on behalf of the company, but you're not taking personal liability for it unless you own the company. CE mark and UKCA, because they mean the same thing. It means when you put that on your product, you have applied all the appropriate provisions of all relevant legislation. So that's where we stand today on UKCA and CE. As I said, there is a new EU framework. It's working on at the moment. There's consultation has gone out and they've received feedback on a revision to the new legislative framework. This is part of the rollout of digital product passports. So it's going to be a big change in the way in which we present to the market our compliance criteria. It's also going to look at conformity assessment processes to remove inconsistencies between directives and regulations. So that might mean slight changes to the way products are tested and assessed. I have to wait and see what those details are. More focus on the quality and credibility of these assessments. So even for self-declaration, how are we going to ensure better quality and better consistency of that? And also looking at the role of notified bodies and how that. And then market surveillance. There's a revision will also strengthen market surveillance rules to protect consumers, professionals in work environments from unsafe products. And that's what products made in the EU and also imported into it. So really a tightening of existing rules, but we do need to keep an eye on it because of these, the devil is in the detail. So where are we with this? Well, draft legislation is expected towards the end of next year, with implementation in 2027 or early. So it really is a watch this space. And just be aware that in the meantime, there's going to be revisions to many of the CE marking directives and regulations to allow digital declarations of conformity and digital instructions. So be careful with this, don't jump the gun, wait till the rules actually change. But do be prepared for modifications and amendments to the existing regulations during next year. This is going to start. Give you the option. You won't be mandated to use these digital systems, but there will be an option to provide digital declarations of conformity and digital instructions for product safety going forward. Details in each individual directive and regulation, but that's just really a heads up for next year. So that's just a brief introduction of where we are with regard to the CE marking regime. And in the presentations that I'm going to follow, I'm going to talk about low voltage directive electrical safety, EMC, radio, a bit on WEEE and Roche and REACH as well. So we'll dive a little bit more detail into the specific sets of regulations as we go forward. Okay, before we go on to the next slide, there we are. Right, thank you, Barry. I was just about to say I can't see my slide. We'll go into the second presentation. Again, if you've got any questions arising out that first presentation, then add them onto the chat, and then I'll address those when we get to the end of this. Before we get to the break. So, safety of electrical equipment. So principally, I'm going to talk about what we would refer to as the low voltage directive, or the electrical equipment safety regulations, which is the UK implementation of that. And there is a electrical equipment safety regulations Northern Ireland as well, which links into this. So the principles are the same for the whole of the UK, even though we're following UK CA and CE rules. In theory, but in practice, most people are following CE regardless of where they are. So, low voltage directive been around for a very long time. It goes back into the 1970s. It was one of the first directives. It's called the low voltage directive just for an ease of naming it, because its title is on the harmonisation of laws of the member states related to making available on the market of electrical equipment designed for use within certain voltage limits. So. It's a very long-winded way of describing, and hence the low voltage directive. It's low voltage because it covers the voltage range of 50 to 1,000 volts AC and 75 to 1,500 volts DC. So an interesting definition of low voltage, probably something which the electricity supply companies have defined rather than the product manufacturers. So low voltage directive, and it's implemented in the consumer safety regulations, which also covers UKCA now. Sits alongside that is specific safety of radio equipment. So the general principles of the low voltage directive could be most sort of household, domestic, industrial, commercial product. Except for radio equipment, which have its own set of rules. So the radio equipment directive or the radio equipment regulations exist to cover that. In practice, though, safety of radio equipment is the same as the low voltage directive, because under Article 3.1a of the radio equipment directive, it refers you to 2014-35 EU directive, which is the low voltage directive. The difference, though, is there's no voltage limit applying, and in practice it's the lower voltage limit it removes. So if you put a radio in a product, then the requirements of the low voltage directive thus apply from 0 upwards, so there's no exemption for low voltage product. Now the original low voltage directive started at 50 volts AC and 75 volts DC, specifically to exclude telecoms equipment. So it was an intentional but lower voltage limit. What the radio equipment, which also covers telecom products, does is it takes that out. So anything with a radio in it, even if it's battery powered, has to have the requirements of the low voltage directive applied to it to protect against electric shock and fire. So these days, almost everything has a radio in it. So we need to look very broadly at how you apply these electrical safety requirements. So what are we trying to do? Well, this is the safety of electrical equipment, not electrical safety of equipment. It's important to note. We'll look at some of the examples later on of what you might need to protect against. But effectively, it's everything. It's what risks are in a product. So all risks to the safety of the user and the installer and maintainer need to be considered under the principle that the equipment shall not cause death or injury to persons or domestic animals, nor damage to property due to fire. So this is effectively the ethos, what you're trying to aim for in satisfying the requirements for electrical safety under the low voltage directive or under the Radio Equipment Directive. So fairly broad principles. And these are real world issues. You know, here's some examples here. We've all heard of instances of washer dryers burning kitchens down. The Grenfell Tower disaster was apparently started by a fault in a fridge freezer. And you'll all recall Samsung's problems with its phones, where the batteries were catching fire and were banned from aeroplanes. So this is not a hypothetical issue. It is not. It's not something that we don't need to worry about. It definitely is. And in all of these three examples I've got here, and with many others, these will have all been CE compliant products. So things have been done, assessments have been made, but things have gone wrong. So if it can happen to big companies, it can happen to small companies as well. So we do need to be aware and not dismiss it as something that, oh, it'll be fine. And if we look at some recent product recalls over the last few years, it's not just domestic products. This was a Schneider Electric circuit breaker, miniature circuit breaker. It contained a non-conforming component, which meant that the breaker might not work when it's supposed to, which is not good. And product recalls were taking place or replaced on site. Hugely expensive for Schneider because of an error made with the product. Another one, which was a power supply for use on a laptop computer. In this case, when you dropped the product, the case split open and exposed bare live mains connected parts, which is a huge risk of electric shock, and the product's missing safety instructions. It was an online product removed from the online marketplace, but it was designed, somebody thought they met the requirements of the standards somewhere along the line, but they didn't ensure that they continued to comply, or they applied the standards incorrectly. And last but not least, this is an example of a low voltage product, in this case, battery power tool, didn't have an adequate battery management system, and therefore during charging was liable to overheat. We've seen the examples of e-cigarettes and electric bikes also have the same issues. So it's not just consumer products. Industrial and commercial products have problems and need to comply as well. So when we're thinking about product safety for electrical equipment, there's three things we need to know. We need to know who's using the product. Is it a trained user or a lay person at home? What's the product's function and intended use? So how is it supposed to be used? But also you need to think about how it might be reasonably misused. And where is it used? What environments? Because that's going to affect the degree of compliance that needs to be applied. And this leads us to how we determine compliance. So part of your risk analysis for electrical safety is the who, what, and where, so you can determine the how. And this is why the directives have the requirement for do a risk assessment. Do this at the very start of the process, so you understand the context that of how you're trying to demonstrate compliance, and so you don't miss anything. For electrical equipment, who? It could be in a factory or workplace. It could be being used by trained professionals, like the forklift driver here, who can be expected to comply with more rules and regulations. It could be a lay person, somebody operating in a school or a shop, doing cleaning work, who is interested in keeping the place clean and isn't at all technically aware. It could be in an education environment where you're dealing with lay people, but also young people, children. It could be while we're out shopping. It could be while we're in the office, when we're working in factories, everywhere, basically. So the who is using it. We can be as householders, we can be as employees, we can be as people wandering around a National Trust monument. We could be using these products or coming in contact with them. what's the function of the product and intended use? So, you know, the examples we've got here, we've got washing machines. How is it supposed to be used? What are the limitations on use on that product? Very different to a centrifuge or a piece of laboratory equipment, or an electrical alarm control panel, or some form of medical kit with a radio built into it. But we need to define that the washing machine's intended to be used by who and where. You wouldn't let the same people who use a washing machine necessarily without training use laboratory equipment, or go inside a panel, or operate radio equipment. So the function needs to be clearly defined, because that'll tell you what risks apply to the particular users in the particular environments. And those environments are very different. Industrial factory, shops, kitchens, out in the street, you know, panels, people working outside. We've got a situation with electric vehicles now, where we've got electric charging stations outside and cars which are outside and cables passing in between them. Different sets of risks. You've got different sort of environments. Inside, it's a relatively controlled environment. If your product's going outdoors, you could be exposed to extreme heat, extreme cold, dust, water, all very different from an office environment or a domestic environment. So you need to consider where it's being used when you do that risk assessment. So what do we learn when we apply the three factors, the who, what, and where to this product? Here we've got a standard Apple mobile phone. So when we look at that, the who, well, the who can be anyone, including children. So we need to think about how children might use this product, or older people. What does it do? Well, it communicates, it connects to mains for charging. So the communication, there are risks associated with that in terms of frying your brain potentially, unless the modules are correct. And how does it connect to the mains for charging? Is the charger safe? And the where? Well, it tends to be indoors, and if outdoors, we tend not to try and get our phones wet. Even the manufacturers will tell us that they're waterproof. So you really don't need to think about extreme weather with a standard mobile phone. But if this was a mobile phone to be used by the military, or to be used for people working outdoors all the time or in very cold environments, then there may be additional factors you need to take into it in your risk assessment. So a mobile phone for consumer use is going to be different perhaps to a mobile phone for professional use. And that's where your risk assessment comes in. And you as the manufacturer define that who, what, where. Then you can go and work out the how. When we get down to the how, we're looking at essential requirements. Now, the Low Voltage Directive, because it was written in the 1960s and published in the 1970s, doesn't use the term essential requirements. It has something called principal objectives for safety, which sounds rather grand these days. But it's the same thing as essential health and safety requirements. So you read the two the same. So if you look in the back of the Low Voltage Directive, its essential requirements are covered in three big sections. The first bit says general conditions, the essential characteristics, the recognition observance which will ensure the equipment will be used safely and applications may and should be marked on the equipment, or if not possible on the documentation. In other words, warnings, instructions for use are a mandatory legal requirement. B says that the equipment and its parts shall be made in a way to ensure it can be properly, safely constructed and connected. So it's saying you need to be able to make it properly and safely. And that's to do with the documentation and manufacturing process. And C, the equipment shall be so designed and manufactured to ensure that there's adequate protection against the hazards detailed in the following parts of this regulation. So in other words, you have to take into account the necessary hazards and take specific measures to deal with those. First of those measures, protection against hazards arising from the equipment. So it says you need to apply measures of a technical nature as per point 1, to ensure that persons and domestic animals are adequately protected against the danger of physical injury or other harm which might be caused by direct or indirect contact. In other words, touching it specifically or being connected to something that touches this equipment. So quite broad requirements. It should be proof against high temperatures, arcs, radiation, which might cause danger. It needs to be protected against non-electrical dangers, mechanical hazards, sharp edges that are caused by electrical equipment and are revealed by experience. And the insulation is suitable for foreseeable conditions. In other words, it must be protected. So in the event of a fault, you shouldn't have an insulation failure that's going to cause an electric shock. Item 3 talks about external influences, the same technical measures. So meets the expected mechanical requirements so that people are protected. In other words, it's suitable for the temperatures, that it's suitable against being dropped, so there's no risk going to be associated with that. It's resistant to those environmental conditions. And then 3C, does not endanger persons, domestic animals and property in foreseeable conditions of overload. So in other words, when it's being misused, either mechanically or electrically, it still has to say it's still safe. So these criteria to foreseeable conditions and foreseeable conditions of overload are part of the rules in the low voltage directive to cover you, not just when the equipment's being used in normal conditions, but under foreseeable conditions of misuse. So those are very broad requirements. So how do we, or where do we get the detail from? Well, the answer is look at one of the 600 and something harmonized standards that are available, listed in the low voltage directive that's compatible in official journal, EN harmonized standards. These give you best practice and guidelines. So when you're trying to meet, to say, yeah, I don't have any high temperatures, what's a high temperature? How do you determine that? Or rather than you guessing at it, go and have a look in the appropriate standard for that product, and it'll tell you what the specific limits are. So the standards really play a key role here in you meeting those essential requirements. But you are still meeting those principal objectives for safety, not complying with the standard. So regardless of what the standard says, you must always meet the principal objectives, and you must take into account all of the scenarios you identified in your risk. So applying a harmonized standard does not give you immunity from the regulations. You can't just say, I've used 6335 and I'm done. You have to go through the process of risk analysis and ensure that you demonstrate compliance with the principal objectives. So safety of electrical equipment. It's not just electric shock. Obviously, electric shock's really important, but you're protecting against fire, trap, crunch, pinch, heat, RF energy, optical, biological, chemical, batteries, poisonous materials. So it's much more electric shock. It's all hazards associated with the electrical equipment. And as I've said, all equipment must be safe when operated as the manufacturer intended and in accordance with the instructions. That's what the principal objectives are saying. And it also must remain safe in the event of a fault or when accident. So these obligations, these risks, when you're doing your risk analysis, you've got to take into account when people are using the equipment properly and under situations where they might not use it properly. And where a fault might have occurred on the inside of the equipment. So fairly heavy responsibility. So how do we deal with that? Right, well, if you think of a body part or a material that's subject to perhaps a hazardous energy source, whether that be heat or shock or fire, you want something between the person and that part. So you have something called a safeguard in the way. And the way in which a safeguard works is that in the event of a safeguard failing, you would always end up with an injury. So in other words, if you put a protection method in place, it's only a valid protection method if it wasn't there, you're going to cause a hazard, you're going to cause injury to the person or to the property or to the material. So this is what this is saying is, you don't need to safeguard everything. You only need to safeguard if there's actually a risk of harm as a result of it. So the question is the component or material that I'm putting in my design essential? And the answer is, it is essential if in its absence it caused injury or a hazard. So that's fine under normal operation. So if you've got a safeguard under normal operation, if that safeguard fails, and we have to consider the failing of that safeguard, how do you ensure that the body part material still doesn't come into contact with the hazardous energy source? Well, you take into account that safeguard failure, and it gives you a secondary safeguard. So the example of this is 2 levels of protection in cables. So a standard mains cable, this time with an orange flex for ease of looking at it, contains 3 wires, a live, brown live, blue neutral, a green and yellow earth, all inside an outer sheath. Each of the individual wires is also insulated. And in this case, it's a good cross-sectional, good symmetrical cross-section. So the insulation is equal on all sides of the mains cable. So in this case, we meet these criteria of 2 levels of protection, because we don't want to be touching the live wire, because that's going to kill us if it's at mains potential. So we need 2 safeguards, and in this case you have the basic insulation on the live wire, which is the first level of protection, the first safeguard, which is immediately adjacent to the hazard, the mains voltage. And then on top of that, you have the outer sheath, which is a supplementary level of insulation to protect us. So in the failure of the outer sheath, so if you damage the sheath, if you cut through it, then you still have the basic insulation on the live wire to stop you from getting an electric. So we've considered mains cable in this case is likely to get the cord damaged. You may split it. It's not uncommon to see split cable, but the general consensus is that having individually insulated wires mitigates the risk to a necessary extent. So that's the concept of 2 levels of protection. And we need to think about reasonable and foreseeable use and misuse. So reasonable use is consistent with the intended function of the equipment. So what did you, the manufacturer, design it to do? And foreseeable by the manufacturer. So the manufacturer is the expert on the equipment. They should be able to define what's reasonable and foreseeable. And this is part of your risk assessment as well, is saying, this is how we intend it to be used, but how are people going to use it in reality? We have an obligation, if we become aware of how things are being used, to take suitable measures to address that. So let's give you some examples. So, here we have a clothes iron, steam iron here. There was an example. These are real examples, by the way. Here we have the example of customers cleaning an electric iron while it's switched on or just after it's switched on. So from a manufacturer's perspective, is this reasonable and foreseeable? Well, it's foreseeable because people will do silly things. But as a manufacturer, you could say this isn't a reasonable act because common sense tells us not to touch hot things. We're taught that from when we're children. So the customer would be at fault at this scenario. Fine lines sometimes to determine what common sense is, but you can use that as a rationale. We know that we don't touch hot things. We know that irons get hot. And therefore, for adults, this would be a reasonable thing. You don't give an electric iron to children to use. So perhaps the instructions remind people of that. So there are mitigations you can put in. So foreseeable, yes, but it's not a reasonable act. And the same example of this would be a table lamp with a light bulb in it. A table lamp with a light bulb in it, I can take the light bulb out and stick my fingers into the empty bulb socket and kill myself. It's foreseeable I might do that, but it's not considered to be a reasonable thing for me to do. So therefore, table lamp manufacturers don't need to protect against it. Let's look at a second example. So this is an electric oven. In this particular case, a serious fire resulted, burnt someone's kitchen down, actually. And despite warnings in the instructions, users of this oven were taking out the removable trays and shelves and placing items directly on the oven floor, often for Christmas dinner. We're getting a bit seasonal. The oven, you buy a turkey that's too big, so you make space. And this was causing problems, quite serious issues. So what was just ruling here was that this was a reasonable thing for the customer to do and entirely foreseeable by the manufacturer that this might happen. Now, in this particular case, what they've done is they put ventilation slots in the base of the oven, and those ventilation slots were essential to stop the oven from overheating and catching fire. And rather than put in a thermal cutout or some form of thermal fuse to protect against this, they decided just to put something in the instructions, which wasn't adequate. So although not used in accordance with the instructions, it was a reasonable and foreseeable thing for the end user to do, and therefore the manufacturer was at fault. Final example, this was a shock risk, cylinder vacuum cleaners, mains powered, where the customers have been lifting the device by the cord for doing staircases, etc. So when they get to the staircase, lift it up by the cord rather than pick it up by the handle. Lazy, not in accordance with the instructions, but the manufacturer was getting product back with damaged cables and exposed live wires. So in this case, was it reasonable for the customer to pull the mains cable and lift it by the cord? Yes, it's what people do. Was it foreseeable? Yes. And in this particular case, the manufacturer already knew before they got to court that they had similar instances. So your risk assessment needs to think about reasonable and foreseeable. And this isn't about compliance with standards. This is about what the risks are. And so that risk assessment is really, really key. Low voltage directive and all directives and regulations to make sure you've covered all essential risks. So we've looked at some reasonable and foreseeable. Here's an example of something that's unreasonable, albeit foreseeable.
I don't care, mate. Yeah? I feel like
Thank you, Barry. So yes, network rail, barriers, flashing lights, warning sirens, and yet still people will ignore you. So you can only do so much, and then you can't be responsible for the stupidity of some individuals. So risks feed into the principles of designing for safety. So we've got some hierarchy of controls. Those of you who make machinery will be very familiar with this. So physically remove this hazard, replace the hazard with something that's safer, isolate people from the hazard, use administrative controls, in other words, instructions, and then failing that, provide people with PPE. So the key point here is that you have to start by trying to eliminate, and you work your way down the hierarchy only when you've exhausted all practicable options at the current level. Practical options doesn't mean cheapest. So you need to take a safety view here and apply the most appropriate action. You can't go backwards, so you can't swap an engineering control with an instruction set just because it suits you. A bit like the manufacturer of the oven chose not to put the safety views in it, instead just thought they'd put something in the instructions instead. So engineering controls will be things like insulation, fire barriers, guarding, essential components. Administrative controls would be instructions, warning labels, training for industrial products, and then personal safeguards like gloves and safety glasses when there's nothing more that you can do about it. So if we look at hazards in this particular product, we've obviously got electric shock because there's a mains power supply attached to it. There's fire from the power supply, and potentially fire from the lithium battery, and that's probably the greatest risk with this. Is fire. And then last but not least, there are radios in it, so there's radiation risks for Wi-Fi and Bluetooth. All of things need to be taken into account to protect the user under foreseeable and reasonable conditions. Right, so moving on from risks, let's just have a very quick look at functional safety systems. Any control system is regarded as being safety related if it contributes to reducing any risk to an acceptable level. So it could have been one of these mitigation engineering considerations in your hierarchy, but a functional safety system is something that ensures that the equipment functions correctly and maintains that level of safety that we want. It's a safeguard, so if it fails, it must do so in a safe manner. So you need backups. At 2 levels of protection needs to still be able to be beat in. So functional safety generally we consider with regard to industrial machines, safety-rated control systems that stop you from chopping your hands off or robots from hitting you. But the concept's becoming more common in other equipment, so things like domestic appliances. So almost certainly if you've got a modern washing machine, you don't have a physical switch that prevents you from a mechanical thermal device that stops you from opening the washing machine door as you used to. The chances are it's an electronic system on a timer that does it. So within there's a control system that needs to be safety proof in order to provide that right level of protection. So in terms of functional safety, there are some standards that you can use. Typically, when we're talking about industrial equipment, things complying with the Machinery Directive or the new machinery regulations, which are coming in January 2027, so not very far off. 2 standards we perhaps think about are 13849-1 and 62061. And these are subsets of the IEC 61508 series of standards, but these are more applicable to products rather than systems. And if we look at this in terms of switchgear, CAPIAL, who are a coordinating committee for manufacturers of switchgear, noted that the fact these 2 standards exist can cause confusion. A lot of machinery standards say, oh, choose either or of these, and they're in favor of actually product standards being clearer in defining you as to which one you should follow. Now, the simpler of the 2 is 13849, but the principles are largely the same. So if you're making a relatively simple control panel for a relatively simple machine, then it's usual for 13849 to be used. And that includes a whole plethora of terms, which I won't go through in detail here. But these are technical terms that help you assess the reliability of any given control system. There's a 4-stage approach to applying this standard. The first is the machine builder. So rather than the control system, but the machine with the risks in it, the machine builder does their standard safety control risk assessment for each function, 12100, whatever normal machinery safety regulation assessment that you do. And they identify the risks that need to be protected. So assuming no safeguards present, what risks need to be protected? And then under 13849, we have something called a performance level, which is the safety measure requirement. So it's a PLR, means it's the required safety level as defined by the machine builder. So really only the machine builder can determine what risks they want protected. And then it's up to the safety system control system designer to implement that. So what they do is they devise a system architecture that's suitable for the level of protection that's been identified. They validate the design to check that it meets the requirements of the risk assessment. So it's a specification effectively for safety from the machine builder to the control system, the designer. And once the design is done, then you validate by testing and assessment that the control system actually does what it is supposed to do. Now, for the machine builder, the assessment of risk is fairly simple, been around since the dawn of time. You assess the severity of risk. Is it slight or is it serious? We've followed a serious route here. Then you look at what's the frequency of exposure to the situation. Well, in this case, we've gone down a short route, so it's a serious injury, but you're not exposed to it very often. And then what's the possibility of avoidance? So are you exposed very, very directly to it, or is it possible to avoid it with some degree of reliability, or is it not? Is it going to take? In this case, we've gone for something that's possible to avoid. So it's serious risk of injury, not common exposure, and it's possible to avoid it. And what this table gives you is a medium risk of C. So C is a medium risk, so E is the highest, A is the lowest. So C is a medium degree of risk. So you could get a PLR of C to 13849 to the control system manufacturer, and they can use that information to go and design the control system. And for those of you who are more familiar with SIL system, which is what we use by 62061, there is a correlation between SIL levels and the PLRs used in ISO 13849. So in this case, a C, PLR C is equivalent to SIL 1. So if you are the control system designer, then there's some defined architectures that will help you achieve the necessary PLR. So a Cat 1 basic system, which has got an input and output and some logic in the middle. A Cat 2, which has input, outputs, and some form of testing of the logic system to make sure it's still working. Cat 3, where you have two parallel systems that talk to each other while they're going along, and make sure that they are that it's all still working properly. And then finally, you've got a category 4, which is a very high level, independent, cross-checking multi-channel system. So really, really for high risk areas. So these are typically the choices of architecture that are available to the system designer. And then 13849 has a simplified stage whereby you can link what you need in terms of PL and your category of control system. Now this is linked to medium time to destructive failure. So you need to do an assessment of the reliability of the components used in your control system. So it's the architecture, the category is along the x-axis, the required performance level on the y-axis, and then it embedded onto that is an assessment of the reliability of the control system in that category. So if we have a look at PLRC, that gives us a range of options. We could have a category 1 relatively simple logic system, which uses components and parts of very high reliability, or we could go with a cheaper category 3 system with lower reliability parts, and it would perform the same function. And so it's up to the control system designer to decide what's best. And it might be that they already have a category 3 system that's tried and tested, easy to use, off the shelf, rather than have to design a very high reliability simplified Cat 1 system. So this is where the cost benefit analysis comes in. Okay, another safety factor to consider here is electromagnetic compatibility, particularly for functional safety and medical equipment. We need to demonstrate that the equipment isn't going to be affected. These safety systems we put in aren't going to be disturbed by the presence of radio devices. And if you use the 620601 standard, it calls up specific EMC immunity standards and tests that need to be carried out. 13849 doesn't have specific requirements, but includes recommended routes in the informative annex. So one way or the other, you still need to do it. And for example, for medical devices, there's a specific standard for but even if there isn't a specific standard, you still need to take this into account. So we're back to our risk assessment. What's the hazard in the environment? If there's electromagnetics present, how could that defeat the safety control system? Okay, so enough on functional safety. Let's just very quickly look at some example low voltage directed hazards. And I've used examples here from an information technology standard, IEC 62368, just because it's quite clear in what it does. The principles outlined here, albeit the values may differ, but the principles are the same, broadly useful for examining what we're doing. So these energy source limits we talked about, what is a safe temperature, what isn't, etc. 62368 includes that. So it would define, for example, for thermal injury, a low risk would be anything less than 48 degrees Celsius. Anything high risk is greater than 58. And then you can apply the same thing to mechanical injury. What's a dangerous weight? What's a dangerous power that might cause fire? What's a dangerous electrical shock level? And how does that relate to wet and dry environments? So energy source limits you will get from your harmonized standards. In terms of electrical shock, if you're looking at electrical safety insulation, think of your lumping loud power brick for your laptop or your mobile phone. You have a 13 amp plug at one end, and then you have a block. Within that block of plastic will be a transformer, and in that transformer you'll have 2 levels of safety insulation, and you'll have an enclosure. The enclosure is a mechanical enclosure to stop you from touching the hazardous live parts in. It's also an electrical enclosure to stop you getting a shock, and the mains and the low voltage parts that we're likely to handle on USB ports and what have you have got insulation inside. So this is a typical example of 2 levels of protection. In this case, the enclosure actually is a single enclosure, but it meets the requirements for 2 levels of protection due to its design, thickness, and material choice. So that's electric shock. Other energy sources, very popular these days, batteries. We know all about battery risks. Batteries have ratings. You can get some extremely powerful ones. The one on the right-hand side is a 10,000 milliamp hour, so a 10 amp battery 37 watts for a whole hour. That if you get a battery pack, it can have multiple ones. So even in the battery packs you use to support your telephone, you can easily have 2 or perhaps 3 of those batteries inside of it. So a huge amount of energy. And the ratings for batteries are for continuous delivery. Under fault condition or overload, it will definitely exceed more. So battery power packs are a really big issue, and we need to give special consideration to that when we're designing. So let's have a look at an example on lithium batteries. That was a relatively small battery, and you can tell by the some of the audio on there that the people doing the test weren't necessarily expecting it to be quite that violent. The problem with lithium cells is that once they go, they go. And we all know about the problems with electric cars when they go wrong, and that's a really good example. From a product perspective, though, even small batteries, I think, is so we're looking at fire. There's some useful guidance in the standards. So typically low risk, anything less than 15 watts as a guide, as a rule of thumb, under fault conditions is not likely to cause ignition. Anything less than 100 watts, you can start a fire, but limited growth and spread because there isn't enough energy really to sustain it. But basically anything over 100 watts can start you a fire. I was told that when I started doing this nearly 40 years ago. Give me 100 watts and I'll start you a fire, is what my senior engineers used to say, and that is equally true today. And when you're considering fire in products, you do need to think about how that fire spreads. So fire tends to go vertically, so you get the concept of flame cones here, which is a useful one from this particular standard, but it is used in other standards as well. So it's not about the point of ignition, it's also about where do you think the fire is going to go? What measures do you need to take at that stage? These are all design considerations. We looked at batteries as a critical thing here, but I think we need to think about USB power. We're moving towards a USB-C powered society. When USB first came out, it's USB 2, it could deliver about 2 watts of power, really, really low power devices. And then over the years, that has the amount of power available from USBs has gone more and more and more as we've been more demanding on the products that it's been powering. But it's typically been very low power. We've now got to the stage with the latest generations of USB where it will deliver more than 100 watts. So we can't assume that a USB port is harmless. It might be harmless from an electric shock viewpoint, but in terms of delivering power that could cause a fire, we need to challenge those assumptions and think carefully about the designs that we're doing. I'll leave this slide up here. This is just some examples of temperatures that will burn you. It's just to give you an example here of different levels of risks and for different materials. So metal parts are going to will sustain a lower temperature before they burn you, or a higher temperature before compared to wood, for example. So you can get a temperature perhaps of 140 degrees on a wooden surface that you don't touch for more than a second, but the same surface at 70 on a metal would be the limit. So there's various limits depending on the materials and the risks associated to it. So you need to take these into account when you're doing your design, and the standards can help you here. But I think the main part when you're thinking about electrical safety is to consider all of the risks. And you know, there's 10 on the screen here, but there may be other risks that the standard hasn't considered that I've not touched upon here. You as the manufacturer, because you're responsible for that CE mark at that risk assessment stage, needs to take that into account. Okay, that brings us to the end of those two sessions. We are running a couple of minutes behind, but if we've got any questions, I could perhaps take one of those. Barry, how are we for questions at the moment?
I'll read out that again. So the question was, when an EU directive is replaced by a regulation, is it the regulation that should be listed on the on the product EU declaration of conformity, or do you still list the directive, or do you list both?
The regulation will replace the directive. So the machinery directive is a good example. Currently, it's the machinery directive. When the machinery regulations come in, they will supersede at the end of the transition period the machinery directive. So it's a one or the other. So you can continue to use the directive until it officially is withdrawn, and at which point you then have to use the regulation. So you'd never list both. It's an either or.
Okay, I have a question and a follow-up question as well. And so the first question reads, is CE marking only relevant for the sale of equipment? I.e., if within a company equipment is built but only for use within that company, is CE marking applicable? And then the kind of follow-up element to that, this part two, is if equipment is brought into a company for use with CE marking, then if changes are made within the company by the company, how is the CE marking affected? In brackets, the equipment will not be sold on.
Right. Okay. So the first scenario, when you're making something for yourself, no, you don't need to CE mark it because you're not placing it on the market. It's just for internal use. However, the health and safety regulations require you to apply all the technical criteria of CE marking, even though you're not going to CE mark it. So the technical route to compliance is identical, but you're not going to CE mark it, so it's not going to be sold. But you still have to go through all the technical criteria of testing and assessing and documenting. That doesn't go away. The only thing that does is you don't need to do a declaration of conformity or CE mark it. The second question, if you bring a CE mark piece of equipment in to your company and then you modify it, effectively it was CE marked when it's placed on the market. If you modify it, it's not going to be sold, it's just for internal use. Then once again, you as the person making the modification take on responsibility for the safety of the product, and you must produce the documentation, do the testing and assessment as though it was being CE marked, but you do not CE mark it because it's for internal use only.
Okay, we have one more question just submitted. And that says, so if a person who has SME electrical manufacturing company in India and wants to supply the product into the UK or Ireland, then how can they apply for UKCA/CE mark, and what cost would be applied? Because for what they've searched in India, the manufacturer needs an ISI mark. So just let me know if you need me to repeat any of that.
So this is made in India, but supplied to the EU.
Supplied to UK or Ireland, yeah.
Okay. in which case the ISI mark doesn't apply because that's an Indian national mark. So that would be for use with the Indian market. For the UK market, it's purely CE marking or UKCA that you would need to apply. And how you apply that, whether you need to involve third parties or not, will depend on the directive. You can choose voluntarily to use a third party to assess your product for CE. Numerous UCAS laboratories and certification bodies, notified bodies that will help you with that. Beyond the, you can go and have a look on the notified body page if if the directive or regulation requires a notified body. But otherwise, in the UK, the UCAS website will list bodies that can help you. And I will add Element do a lot of test and assessment. So we're one of many. There's plenty of others are available. So there's no mandatory third-party marking. You're guided by the rules for CE or UKCA. So you need to look at each of the directives, decide what the rules are, and then you produce the evidence that goes into the technical file. And either that evidence has to be by law compiled by a notified body, or it can be compiled by the manufacturer. And under those scenarios, then you may choose to use a third party to help you gather that evidence, normally doing the testing. Okay.
Great. And time for one more.
Yep.
Okay. So if CE marking is a form of manufacturer's self-declaration, can it be verified by the consumer?
The answer is no. CE mark's not intended for the consumer. The consumer just has to trust it's been done properly, or trust that the retailer who's put the product on the market or the distributor has done necessary checks on their behalf. And there are rules in CE marking that require retailers, distributors to do appropriate checks. But no, it's not intended for the consumer. There's insufficient information for them to make a judgment.
Super. Okay, that's all the questions we have so far. Now there is a session towards the end where we'll have time for more questions, so please do keep popping them into the chat. We'll keep an eye on them, and I'll pose them to Simon at the end of the session. So that's just coming up at 5 past. Take a 15-minute break, Simon. I know you've been doing a lot of talking, so you probably need it more than anybody.
Yep, we'll go that. Come back at 11:20.
11:20. We'll see you then. Thanks very much, folks.
All right, see you then. Okay. Right. Thank you, Barry.
Over to you.
Okay. Right. Welcome back from the break. We talked about sort of an introduction to CE, UKCA, and product safety in the first half of this session. In the second half, we're going to talk about EMC. We'll look at radio and a bit of cyber security, and then so we're just going to finish with a briefly just touch upon protection of the environment, and then we'll take questions. So thank you for your questions in the first half, and please continue to ask those questions, and we'll answer those at the Q&A session at the very end.
I just need you to click on the slide just to activate it. There we go.
That's it. Okay, good. Okay, so the EMC directive and associated UK regulations, which implement the directive into UK law. For CE, UKCA, the rules are effectively the same as with product safety. So what is the EMC directive requirements? Well, it's assessing a device's compatibility within its operating environment for two aspects. So emissions, so the equipment must be designed that it does not emit radiation that interferes with other equipment, including radios and telephones, but not just that, with a level set out by the relevant standard. And in the UK, it's monitored by Ofcom, but there's a different regulator in each country that looks after the radio spectrum to make sure that when we use a mobile phone, the signal is clear, isn't being interrupted by machinery or heavy plants somewhere. And that's common with a lot of EMC regulations around the globe, which are focused on restricting emissions. So designing equipment to be quiet, EMC quiet. The second factor is immunity. And that's making sure equipment operates as intended under expected interference with the level set by the relevant standard. This isn't a universal approach. It is within Europe and the UK, but for example, in the United States, they only have emissions and they don't do immunity testing. But immunity just means that the equipment must also be proof against unexpected immunity in the environment. So if you have an equipment that's fully compatible with the EMC directive, it is both quiet in terms of its own emissions, but also very resilient against the emissions in the environment around it. So generally, two sets of assessments that you need to consider when you are doing EMC. The EMC directive applies to single functional units, and that includes apparatus ready for use. It includes modules like Raspberry Pi, plug-in boards or PCs must comply with the directive, and any component with active electronics. So the example I've given here is a miniature circuit breaker, to be used in a household consumer unit. Of itself, because it has active electronics, must be fully compliant with the regulations. So it's whole equipment, apparatus ready for use by non-technical people, and modules, and also any components with active parts. So quite a broad scope. There are some exclusions though. So fixed installations. So if you're building it into a factory, then no CE marking, no declaration of conformity, but the same principles of not emitting and not being susceptible to immunity still apply. And anything that you self-build, although again, you can't interfere with the radio spectrum, even if it's a self-build product, but technically they are outside the scope of the directive. We have a look at electromagnetic interference. So the simple example we've got here is a domestic environment where you've got a mains supply circuit into which you have a vacuum cleaner, and perhaps elsewhere in the house a television set. So they're sharing the same electrical supply. You get potential for radiated electromagnetic interference. The vacuum cleaner, when it switches on, can make electromagnetic noise that could disturb the picture on the television set, or conducted noise from the vacuum cleaner could go into the main supply through the wiring in the house and back in through the main supply to the TV, hence causing interference. Either way, you know, anything that causes a product to lose its functionality is not permitted. So in this case, you'd have to look at the compliance of the vacuum cleaner. Why is it being noisy? Why is it emitting radiated or conducted noise that's going to interfere with other products? And also the TV monitor itself, to say, why are you susceptible to this? What measures have each applied? And in theory, if both vacuum cleaner and TV manufacturer apply the rules, this situation should not exist. So how was electromagnetic interference caused? Well, in this case, this is a simple example of a switching on a main switch. In theory, when you switch power onto a device, you get a nice clean, so there's no voltage, and then suddenly there is voltage. In reality, circuits are not perfect. They have inductance, they have capacitance, they have impedance, and therefore you get just a simple switching action of mains can give you noisy action. And that switching action can also be semiconductor switching, low voltage switching, but the principle is the same. You don't get as clean a cut change, and that change then causes unwanted signals to occur. Now, that's not good from an interference or susceptibility viewpoint, but equally from an energy efficiency perspective, you're wasting an awful lot of energy in this unwanted signal or waveform. So both in terms of product interference, but also in terms of energy consumption, you want to avoid electromagnetic interference. As we've seen, like the vacuum cleaner and the TV, we want them to be able to coexist and operate properly. They need to operate without interference. They need to comply with the regulations and standards, and there are lots of standards for EMC on particular products, just like there are safety standards. We want to improve reliability and safety. All that wasted heat due to inefficient switching. And we want to make sure that when we buy a product, that it's compatible with the environment we intend to use it into. At the end of the day, as customers, we want to remain satisfied with what we bought, whether that's on a personal level or a commercial level when we're buying for work. There are some safety aspects. We've talked about this earlier, safety-related interference, the machinery directive and new regulations. Where there's electronic controls, there needs to be immunity to external radio interference, and there are specific tests that you carry out for that. We already mentioned EN IEC 62061, which calls up community standards in the 61000 series, and then Annex L of 13849. We did mention earlier on that for medical devices, there's a standard IEC 60601 that again applies immunity test levels typical of what you'd find in a hospital environment. And the hospital environment aspect, it can be actual in a medical facility, but it can also be in something like an air ambulance, a helicopter, or a vehicle ambulance. We touched on as well that electronic controls are not just within the remit of machines, so therefore anything with functional safety will tend to have a requirement to assess the electromagnetic interference risk as part of the safety assessment. So here's the overlap between EMC and product safety. So product safety will be looking at electromagnetic interference potentially when you've got electronic control circuits as being part of what it's looking for, not just a functional thing to keep customers happy. So it's worth bearing that in mind because these lines are getting blurred with the development of technology. So what sort of EMC tests? Well, the EMC standards is all test. So you do your risk assessment, the who, what, where, you work out the how, and then you perform tests generally with published standards. So there will be over-the-air radiated emissions and radiated immunity. And then you have conducted emissions. So that can be harmonics on the waveform, strange voltage fluctuations, so surges and dips. And then you can have conducted immunity, which could be, again, surges, fast transients, conducted RF immunity. And then I suppose last but not least, electrostatic discharge onto the outside of the enclosure. All this will depend, some of these things won't apply if it's not mains powered, but even if it's battery powered, you're still going to have the radiated effects and potentially electrostatic discharge. So when you're doing your assessment, your risk assessment for EMC, you need to take those into account and then draw up an appropriate test plan that covers all of those risks. I said there's lots of standards available. Most of them would be EN standards, but they're largely based on IECs for both immunity and emissions. And this is the structure of the committees that do that. So CISPRA standards look after test emission methods, and then there's a series of emission product standards that you might be able to use. We'll be familiar with sort of CISPRA 32 for IT equipment, CISPRA 11 for measurement equipment, CISPRA 14 for appliances. And then IEC TC 77 committee looks after immunity. These are being developed, fortunately, at international level, so not just in the EU, but beyond, and then adopted within the EN standards system. So for emissions, there's defined ranges at which these tests and assessments are applied. At the lower end, up to 30 megahertz is conducted emissions, and there's a band between 9 kilohertz and 150, which there's a specific set of tests. Then up to 30 megahertz, and then radiated emissions up to either a megahertz or 6 megahertz. These ranges are being, reviewed by CISPRA, IEC all of the time as technology develops. So that's conducted and radiated. If we were looking at conducted emissions, so the typical test setup, where we've got an artificial main network between the equipment and the receiver, where we're doing the measurements, and that network just stabilizes inductance and capacitance to make the measurement more predictable. So in here, we would be making measurements of what's coming out the equipment, going down the supply cables. You end up with you're working against conducted emissions limits. So these are limits taken from the standard, typical standard. So here you can see the emission line. The top one is the quasi-peak, and that's a peak level that provides a steady state. So in other words, the normal noise that's happening all the time of equipment, the peak of that is considered to be steady state. And then there's a new average line, which is for impulsive signals. So this is the average of all the waveforms, and that takes into account signals that only occur intermittently, which would be permitted but can't exceed the limits. So those are the limit lines which you see in the standards, and then once you do the test, you get a trace out of the receiver that looks something like that. In this case, it passes both on quasi-peak and average, and you can see where the noise is with regard to this. In this particular product, the noise is in that 150 kilohertz, and then again up above the 10 megahertz, but well within limits. For radiated emissions, these are through the air signal, so the measurement is taken at a set distance between the equipment and an antenna and receiver. Quite straightforward. And then you end up with a set of emission lines again, and those coloured, the sort of purple, red and blue, are different lines for different standards. So depending on the standards that you're adopting will determine what limits are applicable. So you have to use these harmonized standards to take these, to make sense of these measurements. And once again, you get this is a peak limit line. So the measurements here are interestingly quite close to that line, over it in some cases. So there may be some further investigation needed on this radiated emissions track. If we look at immunity, a different spectrum here. We're not so interested in that sub 150 kilohertz, and different dividing levels between conducted and immunity, where conducted emissions goes up to 80 megahertz, and from 80 to 6,000 for radiated. And for immunity, whereas for emissions, you're just making a measurement and saying, yeah, it's emitted, but above or beyond this level. For immunity, we need to think about how it affects the product. So the standards therefore develop what they call immunity acceptance criteria. So which is defined sometimes by the product standard as to which one of these you have to do. Sometimes it's left up to the manufacturer. So acceptance criteria A, which is required for continuous interference. So in the presence of continuous interference, the apparatus or equipment under test must operate as intended with no degradation of performance below the manufacturer spec. The manufacturer sets what the minimum standard is, and then for criteria A, continuous interference, it shouldn't be affected by that. And then a criteria B, which is for transient interference, and this permits there to be some temporary degradation of performance in the event of transient interference, but with no change of operating state or stored data. In other words, you can't change the function of the equipment by the level of interference or modify data as a result of it. So it's allowing some performance loss on a temporary basis, but not permanently. And then there's acceptance criteria C, which is specific where you've got a product which is manually operated, where some sort of manual reset could be done. And that's a temporary loss of function, which you can recover by doing the classic switch it off and switch it back on again. So the different product standards describe how these acceptance criteria are used. But as you can see, there are different levels and which apply to different uses of the equipment. So radiated immunity, it's the inverse of radiated emissions. You're now firing radio waves at the equipment at a set distance. And then conducted immunity, again, just the opposite of the conducted emissions. In this case, we're using a coupling decoupling network, the CDN, to sit between the transmitter and the EUT to give you that, a fair, repeatable balance. But once again, you're looking for this to meet the necessary criteria. Then if we look briefly at some of the other immunity issues that you need to design your equipment for, voltage surges coming down the mains, electrostatic discharge by people touching the equipment, fast burst transients, being conducted in through the signal and control cables, are all immunity threats, transient immunity threats that equipment need to be designed to resist. And various transient waveforms as to what you might get. So ESD tends to be a spike, declining electrical fans, transients, little bursts of signals, and surge is a signal that then dies away. In terms of EMC, what sort of problems can you expect? Well, the standards change regularly, and there's little or no help in them to fix problems. It's just literally test methods. You certainly need calibrated specialist equipment, often very expensive, and you need a stable environment, so you're not measuring what's going on next door or what the signals are from your mobile phone when you want to know what the product is doing. So that this factor is why EMC testing is expensive and time consuming. Test setups are very critical. The equipment you need is very expensive. It's also a problem because almost every newly designed piece of equipment fails and needs some sort of fix doing to it. And regrettably, surveys regularly show that up to 30% of CE mark products in the marketplace are found to be non-compliant when they. So there's a lot of people not doing this properly, or the design is being changed without going through that technical documentation cycle where you go and say, I've changed the product and therefore I need to requalify, even do by partial assessment to make sure the changes I've introduced haven't undermined my CE marking. So what do you do to rectify it? Well, sometimes rectification of non-compliance is simple as a half-day retest and a component of less than £1. Sort it out. And these components might cost you £1 for one, but when you're buying them in bulk, they're a few. So sometimes it can be easy, or it can take months of testing and total redesign, reverting to multi-layer PCBs, relaying your PCBs, additional filtering. It might be poor choice of chip, or it might be that the software is causing issues. So a lot of planning needs to go into your EMC design before you get to the test chamber. Otherwise, you're paying thousands of pounds a day to be told the product doesn't comply. And if there's too many issues, it's very, very difficult to fix. And you end up spending a lot of time in chambers diagnosing things, again, at great cost. So the effort putting in on the design at the front end is really, really beneficial. So if we look at PCBs, sort of common guidance for this is look at the standards, understand the tests and plan for them. There's plenty of information available in the public domain on how you design PCBs to be for a good EMC profile. Filter, shield, and ground, the three main areas to think about when you are designing your PCB. Take advantage of being able to use multi-layer PCBs wherever possible, perhaps with ground planes in between. Limit current into noisy components like MOSFETs to reduce ringing and harmonics. Avoid splitting analog and digital ground planes. Fit ferrites everywhere to try and avoid radiated immunity and emission issues. Segregate noisy and sensitive circuits. So the circuits that are performing the function that you want to protect, make sure they're physically segregated, perhaps barriered from noisy parts of systems. And machineries and control panels, you can have noisy drives for motors next to sensitive functional safety equipment. Ensuring power supplies are not. So there's good design. Decouple everything with multi-layer capacitors, make those close to the IC pins so that you get the full value of those. Terminate all processor pins, don't leave them dangling in the air where they can act as antennas. Minimize ground return loops, and on mains inputs, limit surges and transients by putting appropriate protection methods in. You're making control panels, it's recommended to use zinc plated backplates, but if you're using painted backplates, be aware the paint is often insulating, so you need to remove paint to ensure good conductivity between the parts that are supposed to be bolted to the plate and those which are that are supposed to be isolated. So you may need to remove paint, use serrated washers to ensure a low impedance connection between the earth plane and the multiple earthings in the system. Otherwise, you'll end up with odd loops. If you're making a control panel to be plugged into a machine, make sure you provide the wiring assembler with rules for EMC, where they can run the wires in identical channels. You can segregate parts, but then if the wiring is all mixed up, it's going to cause you problems. And make sure you get consistent internal wirings in panels, and that segregation is documented. Often advised to keep earthing wires and connectors as short as possible, and ensure 360 coverage, no pigtails. Control panels, remember, a standard enclosure. It's got gaps in it, it's got doors and windows, insulating seals. Just because it's a metal box doesn't make it an EMC cabinet, which will be a Faraday cage. If you need the cabinet to be a Faraday cage, in other words, to prevent radiation getting in and getting out, then you will have to fit all sorts of special EMC little fingers on the doors. You have to use EMC glands. Makes it much more complicated, but sometimes you need to do it. Use screen cables at both ends so that that there's no opportunity for the earth wire to be. Segregate interference sources, as I've said before. Fit mains filters and ferrites to cables where necessary. Motor cable for inverters with suitable glands. And the control panel designer needs to know about the risks associated with the equipment they control. And the panel installer needs to know what additional EMC protections are required. So, as the control panel designer, you would have designed in some good EMC practice into that on the basis of what you were told about the machine. But then you also need to provide instructions to the installer to make sure they don't mess that up during the installation phase. So, EMC testing. As an EMC testing laboratory, we see hundreds of customers a year, and we see the common problems. Most common, even now, is people assume because a component part, module is CE marked, that if you put it with other CE marked products, then the CE compliance of the overall product is confirmed. And this doesn't work for any of the CE marking directives, safety, radio, EMC, but particularly with EMC, don't assume. The EMC profile will change with every active component you add into a device. Wires will act like aerials. So you need to make sure that shielding is connected at both ends so they don't become an inverted antenna. Remember that the components that you're using are not perfect textbook components. All capacitors have inductance, all inductance have capacitance. Everything resonates at some frequency. And I think one of the biggest things is that CE approved power supplies or marked power supplies often fail conducting the radiated emissions on the bench. So when you test them just as components, they don't pass. Never mind when they put into end application. However, I think you're worth persevering with a good quality power supply, because designing your own switch mode brings you all of the problems of EMC design to deal with yourself, and that's not a recommended thing to do. Remember that plastic cases do not solve all electrostatic discharge problems. If you've got screws going through the plastic enclosure, it can conduct electrostatics into the metal cases don't solve all radiative problems unless it's a Faraday cage. And it's a Faraday cage, it has to be designed for specific frequencies. It's also extremely difficult, extremely expensive to create a Faraday cage on an operator. When you make your EMC changes, when you stick extra filtering in, extra capacitance in, you run the risk of altering your safety compliance. So you do need to think about your safety compliance and EMC together to make sure that the fixes you apply for one don't undermine what you've done on the other. So finally, real world EMC testing. So EMC directive, the testing isn't mandatory. We said very early on, the essential requirements don't call up specific standards or specific tests. What the directive expects you to be able to do in your technical file is to demonstrate why your equipment doesn't emit excessively or is immune, not immune to external criteria. So it's not mandatory, but some form of evaluation and assessment needs to be done as a way of proof that you've met the standards, particularly if you are going to list standards on your declaration of conformity. This is a key point here. If you put standards on the declaration of conformity, then the assumption is you have applied them in full and you have evidence in your file to show how you've applied them in full. If you haven't applied them in full on your DSC, you should strictly put part next to it or clause done only. Otherwise, your declaration is false. So when you're doing any CE declaration of conformity, if you list a standard on it, you need to ask yourself, where's my evidence in case I've asked for my evidence of compliance with 1000-1-2 for immunity? Needs to be there somewhere. But depending on the circumstances, there might be limits to how much testing you do. It might depend on the complexity of the technology involved in the product. Some products are very, very simple. And you can draw some conclusions in your technical file with little or no testing, or you can use these homemade efforts with homemade radio receivers and using your mobile phone against it. very basic. It'll also depend on your company size and market share. If you're a one-man band with a new design, you might get away with non-optimum testing. If you're a multinational company, that isn't going to be an acceptable method. You haven't been duly diligent. Due diligence does depend on your resources and your size. And also, it's your company's risk perception. You need to do as much as necessary to stop product being returned, complaints in the marketplace, reputational damage. So your attitude to testing and your budget, what you have done where, will depend on all of those factors. But the highest risk, if your technical file contains no testing or technical evidence and there's no proof of compliance, because you've said it's CE plus CE equals CE, I'll list these standards that I've copied from the internet onto my declaration of conformity, it'll be fine. Well, it won't be fine if you get challenged. And as I've said, there's a very, very high failure rate when product is tested. And it's quite easily to come undone from an EMC perspective. Okay, so that's a very brief introduction to EMC. Hopefully covered the key areas that you are that may trouble you when you're considering your designs. I think with all of these, you need to look at those standards and see how it applies to you. Right, for the penultimate session, we're going to look at radio equipment, radio compliance. And this session also includes a little bit on cybersecurity, because that's that new conformity assessment aspect has come into the radio equipment earlier than in some other products. Okay. So Radio Equipment Directive, it's the Telecommunications Act in the UK. The two are very similar. So when does the Radio Equipment Directive apply to product? Well, is there a radio function within the product? Is there Zigbee, LoRa, Wi-Fi, Bluetooth? As soon as you stick this functionality into equipment, then it falls into the directive. Anything with transmitters, receivers, transceivers. Anything with a frequency range up to 3000 gigahertz. And asking the question, is it a radio or a product with a radio inside of it? Regardless, it's radio equipment. As soon as you stick a radio in it, then the Radio Equipment Directive applies. Even if you bought the module in from a third party. We'll examine some of that as we go through the presentations. So the Radio Equipment Directive is actually a complicated beast. We looked at product safety and said that Article 3.1a of the Radio Equipment Directive covers effectively the Low Voltage Directive. So health and safety is a key part. Product safety, protection against radiated emissions that would fry your brain, etc. That's one part. The second part is EMC. We talked about EMC separately, but EMC applies to all radio products as well, and there's very specific radio test requirement, EMC test requirements for radios. And then there's spectrum usage to make sure that your house alarm and CCTV camera at home isn't interfered with by or cross bands with your mobile phone, and that you can't listen to other people's mobile phone calls on your mobile phone, because and you're not finding that your latest PlayStation prevents you using your Hive heating control in your house, or that the microwave stops you from using your remote control on your TV set. So spectrum usage is the other part. Now these were the traditional parts read from the start. Now in addition to that, we've now got Article 3.3 elements that have been added, and that is interoperability. Do radio products work together properly? Cyber security, and miscellaneous factors. And then last but not least, the requirements for a common charger. So from starting off as a very simple 3-step spectrum, EMC and safety requirement, we've now gone into a variety of other criteria that you need to apply. So it makes the Radio Equipment Directive very, very complicated. But that reflects the world that we live in. Our radio products are complicated. Our mobile phones allow us not only to make cell phone calls, but we can connect and control other devices through Wi-Fi, we can access the internet, we can use Bluetooth, and we can pay for things on it. So lots of data is stored in our phone. We have interoperability for payments and such like. So radio devices really are some of the most complex that we would deal with. And hence these additional requirements that have come in to protect this. So if we look at conformity radio equipment, there are 3 routes to it. What we call internal production control, self-declaration, EU or UK type examination, where you need to use a notified body to test the product, or something called the full quality assurance route, whereby you have your factory and design processes assessed to show that your capability to design these things properly. You don't need to involve a third party on individual designs. So the routes are available to you depending on what process you're following. So if you're using harmonized or designated standards and you apply them in full, then you have the choice to either self-declare for internal production control, involve a notified body, or go down full quality assurance route. If, on the other hand, you aren't applying harmonized or designated standards in full, then you are limited to using a notified body or full. So hence the importance of harmonized standards is really key here if you're going to avoid having to use a third party. All of them lead to the CE or UKCA mark, depending on which route you're following, but where you start from is quite different. And if you do the full quality assurance route, then you have to start putting the notified body number of the body responsible for overseeing your quality assurance next to the CE mark. If we look at radio equipment regulations versus the red, harmonized standards and designated standards, the same thing. Notified body and approved bodies, the same thing. Article 3.3 doesn't apply in the UK. So there are other regulations within the UK market. Article 3.3 was never adopted, and Article 3.4 was never adopted in the UK. So if you are complying with UKCA, you don't do Article 3.3 or 3.4. You just stick to the basic 3 EMC safety and spectrum. Because there are other UK regulations that you would apply. So radio equipment, we talked about testing. There's testing needs to be done for electrical safety. EMC probably needs testing. Radio, do I need to test it? Most likely. Like the other directives, it doesn't mandate testing, but the best way to determine compliance is actually to test the product, as we'll see in a minute. Fortunately, lots of red standards are available to help you test. And the great thing, unlike EMC and safety, is these ETSI standards are all free. So you can go and download them. There are lots of them. But your radio compliance standards are available for free. So you can go and see what the rules are and help design accordingly. And if we just look at the radio spectrum bit, the functionality of radio, even within that, there's lots of complexity to it. You know, you're looking at how do you maintain the correct frequency? How do you maintain the right power? How do you maintain, do you stick your emissions within in the right band? How do you avoid emissions outside the band and spurious emissions? When you're within band, how do you make sure you don't exactly stray across the band boundaries? So the standards are dealing with all of these complex features. This is just for radio spectrum. If we look at some examples, so we look at an example here of a device, you'll see here that we've got an intentional frequency, which you can measure, its emission level. And then beyond that, you get harmonics and other frequencies that are around. But in terms of the frequency of transmission, it's quite clear what this should be. So when you're testing to make sure that all the parameters to do with that intentional transmission are maintained whilst the product is being used. So let's have a look at some of the testing. So first set of testing is receiver testing. Fairly straightforward. Will the receiver pick up a signal emitted at the appropriate strength, the appropriate frequency in the appropriate band? If it won't, it fails. If it will, then it passes. So you're testing to make sure the thing actually works. That's receiver testing. And then you need to think about your receiver in the real world environment, because you're not just using radios of your type. There's other people's radios in the market. So what happens when somebody else's radio is present? Does your product, is it still able to receive in the way that it's intended or not? So tests are done in the presence of spurious radio signals to make sure that your product maintains. And to do this, there's various test setups. So you have these, so if you consider a Wi-Fi router here, rather old-fashioned thing, to test this, we would need some form of coaxial connection to monitor the radio performance. We would need some way of putting a signal into it and determining what signals are coming back in. So some sort of connection probably to a PC. Relatively easy to do, common test setups. But you get complexity with something like a battery-powered device, like a Bluetooth in-ear device, where again you need to be able to power it reliably. You won't necessarily be able to rely on the batteries for the length of testing that you're and the type of doing. How do you make the radio measurements? How do you make the coax connection? And then how do you make the data connection to it? None of those three external connections are provided as part of the equipment. So your test plan for radio is quite complicated. You need to make simulations. You need to work out what's an appropriate way of testing the product, and sometimes that's quite difficult. We've said it's a wireless world. People want wireless connected devices. They want Internet of Things, machine-to-machine interfaces. But the manufacturers of the things are not radio experts in themselves in their own right. So industry's constantly being challenged about how do you connect wirelessly. And for this reason, there is a solution. Radio experts make the radio modules. Other equipment manufacturers, like washing machine manufacturers, make washing machines. The washing machine manufacturer installs the module, and then you now have a wireless or radio device. So typically, here's an example here. We take a module and a washing machine. In this case, is the washing machine a radio device? No, but as soon as I put that module into the washing machine, it now becomes a piece of radio equipment, and the requirements of the radio equipment apply. But as we've said before, just because the radio module is CE marked, adding it into another device, a host, Doesn't mean that that CE mark remains valid. CE plus C does not equal CE. And if we look at the harmonized standard, the ETSI standard, ETSI Guide 2032367, it says, if the conditions in which the radio product is used in combination with the equipment deviate from the assessment conditions, then the manufacturer should reassess the combined equipment against Article 3.2. In other words, the spectrum compatibility part of the regulations. So we need a way of knowing whether the combined radio module and OEM equipment remain compatible. Have you disturbed the compliance of the module by placing it inside a piece of equipment? So that's EU rules, just noting that for modules for Japan, US and Canada, similar rules apply. So third-party modules, issues you get unwanted frequencies resonating on PCB tracks within the host. So the module works fine on the bench, put it in a piece of equipment, and the combination with the hardware in the washing machine or whatever distorts the signal on the board. You get unwanted reflections of fundamentals. You increase power because you're effectively shielding the transmitter, making it work harder than it should, and you could end up with weak field strength levels. You reduce sensitivity because you've shielded the receivers on the device by the host construction. And then you get radio frequency signals being generated within the host inadvertently that drown out the signals from your radio module. So you get functionality issues. So not only could you end up distorting the spectrum, but the function that you're trying to offer to your customers may not work. So if we look at an example, so here's our radio module again, and you can see the nice clean signal that you get. If you put it in the washing machine, you might get something like this. So as you can see here, you've got all sorts of odd additional signals that have occurred. So unwanted frequencies resonating in the equipment, causing additional spurious emissions. So the emission pattern of the original module is no longer valid. So the CE mark claims by the module manufacturer have been undermined by installing it in host equipment. Take another example. You can see here there are reflections causing increase to field strength in unwanted emissions. So again, we've now got not a nice clean signal on the intended frequency. We're now transmitting on adjacent frequencies as well, which could cause problems for other radio devices. We've got a situation here. You can just about see this on this sketch. You can see the darker coloured line is only sort of halfway down the original fundamental for the original signal. So there's an impact on sensitivity of the radio modules here. If you design your host properly and you assess the risks, you make suitable design modifications, there's no reason why you can't end up with a situation where the host and radio module sit side by side. And that's what that ETSI standard is saying. When you install a module, you need to be able to demonstrate that the module compliance has not been undermined by that installation. But on some simple products, it's easy to do by assessment or by contacting an expert who will make a judgment, notified body. In other situations, you need to test it, produce some test evidence. It doesn't mean you need to repeat all of the testing on the module, but you might need to do selective testing in consultation with the test lab to be able to put something in your file and say, yeah, my module is fine. And of course, my example was a single transmitter product. If we look at multi-transmitter products, like a mobile phone, much more complicated. And again, there's guidance in the ETSI standards, and it says that in the case of more than one transmitter that can operate at the same time, then a reassessment of the spurious emissions and consideration of potential effects of intermodulation should be performed. So you're going to have a Wi-Fi, a Bluetooth, an NFC, and a cell phone module in here. Each of those modules or chips may have been tested separately. It may work fine when operated in this mobile phone. However, is the cell phone signal going to be operating the same time as the Wi-Fi? Probably. Is it going to be the same time as the Bluetooth? Probably. Same time as MFC? Probably. So if it is, how do we ensure that the compliance of each of those modules is unaffected by its interaction with others? So it means another range of considerations to take into account. So you need to think of the combinations of transmitters, receivers, and transceivers. All radios must be reviewed, even if you don't need to cover all of the red articles. So you're probably just looking at the principally the spectrum management that you would need to do, plus perhaps some of those articles 3.3 for interoperability and cybersecurity. But you need to consider the impact and the overlap of more than one module operating at the same time. So pre-tested and authorized modules are great, saves you a lot of work, but you do need to think about testing in the end, some form of assessment and authorization to show that all that good work done by the module manufacturer isn't undermined by the installation. Remembering that the final product, that washing machine, must meet the requirements of the Radio Equipment Directive in its own right. It's being assessed for its compliance and before the CE mark can go on it. And the manufacturer of that final radio product, the washing machine, is the one signing the declaration of conformity and taking the responsibility for radio compliance. You can't absolve the responsibility and say, I bought an approved module. It doesn't work like that. So follow the guidance available. As I said, fortunately, these ETSI standards are free. Lots of guidance available free. If you want to have a look at it, make sure that you follow the routes. Just a few things to think about, that the module manufacturer will CE mark, but they're CE marking not knowing what the end installation is going to be. So sometimes the test results on the module that we use to CE mark can be important to the person installing in the host. The reality is that the CE mark of the module is less important. Some module manufacturers will share some limited test results with you to help you install properly. But the CE mark on the module itself is really only to enable the module manufacturer to fulfill their legal obligations. It isn't really much help to you as an end equipment installer. So, common mistakes in assessing to the Radio Equipment Directive. It's inconsistency of information. When you're looking at your technical file, there isn't a test plan. There's not a risk of the set analysis done, the risks of the interaction between different elements of the radio or different radios. Sometimes the results are incorrect. Old data is reused when it shouldn't. Sometimes there's no testing in the technical file. It's been done on assumptions which are proven to be incorrect. And missing information, I think, is one of the key things that our notified bodies report. In terms of host equipment in particular, the responsibility for the compliance of the radio bits is sometimes confused. The end host is blaming the module manufacturer, the module manufacturer saying it's not me. The declarations of conformity and risk assessments, the risk assessments are inadequate, don't address all of the operating modes that in reality are going to be used by the radio device. That there's mistakes on the declaration of conformity, wrong standards, wrong years applied, or a great long list of standards being listed on the DOC, but nothing in the technical file to explain how they've been applied or not. There's also a situation where people do loads of testing, when in fact they could have gone to the notified body with a small amount of testing and asked for an opinion. And often that's a quicker way to market than testing your way through, particularly with complex radio products and installation in hosts. And then back to my Wolf analogy earlier on, people closing their eyes and hoping that the risk goes away if they ignore it. Radio is complex. We've looked at some of those complexities just lightly in this presentation. So don't ignore the difficult issues. Expect difficult issues. Do that risk assessment up front so that at least you've got a route plan to try and capture everything. Now, back on our original slides, we looked at those sort of section 3.3 aspects of the Radio Equipment Directive, one of which was cybersecurity. And these cybersecurity rules came in for radio in August of this year. So in the EU, we have Radio Equipment Directive, and then in the UK, we have the Radio Equipment Regulations, more or less the same thing. There's something called the deregulated regulation, which is that Article 3.3 aspect of the Radio Equipment Directive that specifically talks about radio cybersecurity and radio devices. And then additionally for the EU, there's something coming up called the Cyber Resilience Act, which will probably subsume this delegated regulation in the Radio Equipment Directive. So the Radio Equipment Directive deregulated regulation puts specific requirements now on cybersecurity. When the Cyber Resilience Act comes in, it will probably absorb those. Now, the UK doesn't have that delegated regulation under Article 3.3. It doesn't apply for UKCA. And instead, for cybersecurity, we have something called the Product Security and Telecommunications Infrastructure Regime, which sounds very complicated and dramatic. We'll look at those in a bit more detail. As I said, three things we need to look at: red articles 3.3, D, E, and F, those delegated regulations, the Cybersecurity Act, and the PSTI. Note that some testing to prove compliance with these regulations is likely. So let's look at red to start with. Three aspects of here: protection of the network, protection of personal data and privacy, and protection of fraud. Not all parts will apply to all products. So the fraud bit is particularly pertinent if you've got payment systems, for example. If your equipment is holding personal data, then 3.33 is applying. Protection of the network is almost going to apply for everything. All of these articles came into force on the 1st of August this year. There's lots of things around on LinkedIn, on the internet at the moment. And we've been doing a series of webinars and teachings and elements as we've moved towards this. And we're a notified body to cover cybersecurity and radio products. And we only got that this year because it's all coming really, really quickly. And behind this, though, there's a new series of 18,031 standards, and those are developed so manufacturers can demonstrate. So there is a route map through to you once you've decided what you want, once you've looked at the risks that cyber upons you. These 18,031 series standards, though, do look at both document-based and test-based assessment to prove compliance. The Cyber Resilience Act comes into force at the end of 2027, and that covers items other than radios. So home cameras, fridges, TVs, toys must be cyber resilient when they go on onto the marketplace. This new regulation is bringing things together. We have internet connected things in the home at the moment. We're aware there are cybersecurity risks, and this new legislation is designed to bring together requirements to make it easier for manufacturers to design and for consumers to have reasonable expectations of lifetime protection from cybersecurity issues. No standards as yet, but we should expect some standards from ETSI and CENELEC into next year and into 2027. So it's another standards watch, a bit like for the RED cybersecurity, that 18,031 series of standards. Everybody was eagerly awaiting those. It's going to be the same for the standards in support of the Cyber Resilience Act. The third one of these is the UK PSTI, and this ensures that consumer connectable products of smart TVs, cameras, speakers are more secure against cyber attacks. It came into force in April 2024. It has a much simpler set of requirements than the Radio Equipment Directive. It only requires default passwords. It only requires you don't have default passwords. So you don't ship things out all with 000 on it. There must be some mechanism either for passwords to be set in advance, or at first time of use, the user given the opportunity to change. Products must allow users to report vulnerabilities on the product to the company. So there's website requirements and contact information requirements. And the manufacturer needs to tell the consumer how long they're going to support security updates on these products. As I said, much simpler, uses an existing standard ETSI 30364-5. It only clauses a few clauses from that. So actually, you can meet the PSTI relatively easily without really much technical input to it. And in reality, just doing these three things on here, the passwords, the ability for users to report vulnerabilities, and for the company to commit to provide security updates for a set period of time, will do a massive amount to improve cybersecurity. What they're putting in for RED is very good, and is an improvement on this, but we are quite a long way from having that sort of level of security in society. Within that rather complicated structure, and again, you'll be able to have a look at this in the slide deck when it comes out. We are at the now, so about 2/3 the way along towards the right, where we have various regulations, standards published. We are expecting the Cyber Resilience Act reporting obligations to be out in September next year, and then the act itself by the end of December. So they're going to enter into force soon. So it's all change on cybersecurity. So I'm sure many of you are keeping a very, very close eye on such things. There's a very neat flowchart here, which helps you determine what applies to you, which element is produced. Again, when you get the slide deck, you should be able to pick out that. It just says what you want to do and how do I want to do it. So the RED compliance process, lots of areas, very, very complicated. As soon as you get that Article 3.3 for RED, everything becomes more difficult on Article 3.4 than just radio compliance. So remember, risk assessment for all of these things, right at the front end, do your risk assessment. First document are open, like an assessment plan. Who, what, where helps you determine the how. It leads to any test decisions that you need, whether that be for radio or for cyber, and it's a way of documenting your choices. So get that risk assessment, use it as a way of building a compliance plan. It'll make it much easier to get through the whole process, much quicker, much cheaper. After. So the planning phase is really important here. So thank you for that. It's just a very brief introduction into radio. And certainly the sort of cyber side of things is we're getting more information as the regulations are clarified, as new standards are produced. It really is an expert. I'm not a cyber expert by any stretch of the imagination. But there are people out there, companies, as I said, like Element, with notified bodies with expertise that can provide guidance. to manufacturers as they go through this cybersecurity journey. Right, last but not least, just going to very briefly look at protection of the environment and human health. This is just closing off some of the areas we commonly get asked about, which is Roche, REACH, and WEEE, and how do they relate to each other. They all share a similar objective, which is protection to the environment and human health. So there's a common theme to it, but how does it apply to you and where? So let's start off with looking at Roche. This has been around for a while. It restricts the use of toxic materials in electrical equipment, and it stops those same materials from accumulating in the environment after the equipment is thrown out. We are in a throwaway society. So you don't want the toxic materials in it in the first place, because you don't want to cause injury or ill health to us as human beings. But equally, you don't want to poison the environment when it's buried in landfill. The Roche is really aimed at the management of finished products at the production stage. So it's about choices made by the manufacturer, by the designer of the product, and then the manufacturer as to the materials they put into their product. It's relatively clear cut. If you look at the directive, it requires concentrations by weight of less than certain amounts for certain materials, typically 0.1%, but for some matters it's smaller than that. So cadmium, it's 0.01%. So the following materials are covered by Roche and effectively need to be used in tiny, tiny quantities. So as part of the obligations of the manufacturer, they need to design and make choices about materials that eliminate these materials in any significant quantity. So the type of equipment covered by Roche is detailed in Annex 1 of the directive. Household appliances, IT, telecoms, long list. And then at the end of the list, it says any other electrical equipment not covered by any of the categories above. In other words, everything is covered by EE unless specifically excluded. So all types of equipment unless they are on the exclusions list. So if we look at the exclusions list, military equipment, space equipment, and so on and so forth. Rather unusually, some photovoltaic panels and batteries, because batteries are covered by their own set of regulations. So if it's not in the exclusion, then Roche applies to you and you need to eliminate those materials. And a lot of these materials are not just in PCBs and in the enclosures, they'll be in things like glues, labels, inks, rubber knobs and feet, gaskets. So it's every part of the equipment, bought in, built yourself, molded yourself, that you need to consider. Your obligations under Roche, you have to monitor and control these restricted materials. You need to maintain technical documentations on materials and bought-in parts. You may need to test the materials. If you don't know what the concentration is, then you need to have some form of analysis of the material or the part to do this. And most importantly, it's a CE marking regulation. So if you are CE marking your product, you need to include Roche on your declaration of conformity, and in your technical file, you need the evidence of compliance with Roche. Now, as I said, the directive, Article 16, allows for a presumption conformity if you tested standards. There's a standard 63,000. Which enables testing to be done, and then there's a requirement for technical documentation. So I've seen situations where products are made overseas, coming into the EU, haven't had that assessment done, And then what is then done by test labs, they will disassemble the product, or the manufacturer will disassemble the product into each of its component parts, and they would test each one individually using a chemical analyzer to show that there's none of these materials present. So it is feasible to take a manufactured product and test it and prove that you meet the Roche regulations on the basis of a test report. Looking at Roche in the UK and EU, the regulations are largely transposed. So for the UK, just read the inclusions, exclusions from the CE EU Roche and apply. That's Roche. Second one we'll look at is REACH, and this is mainly aimed at the management of chemicals used for the production of the rather than materials. So it's protection against health, and once again to make sure that these materials, these chemicals, don't get into the environment. So it overlaps somewhat with a little bit with REACH and Roche. So for REACH, chemical producers are required to register their safety data for all chemicals produced. So the chemicals going into the parts that are used in equipment must be pre-registered. And the EU and member states will look at chemicals that they don't like, those of concern, and then any that are of very high concern will. And in fact, some chemicals get completely banned or are restricted as part of that process. So REACH applies to companies or individuals that import, manufacture, or place on the market substances, mixtures, or articles. And an article is defined an object which during production is given a special shape, surface, or design which determines its function to a greater degree than does its chemical composition. That's clear as mud. A substance means a chemical element and its compounds in a natural state, including additives, so those are within the scope, and a mixture is a mixture of one or two substances. So an article, going back to that, an object which during production is given a special shape, surface, or design which determines its function to a greater degree than its chemical composition. So that if you mold a chemical material to make something, then that material is again subject to the scopes of REACH. There are some exclusions. They're very, very specific. So your obligations under REACH, you need to make sure you're not using banned substances or importing them from outside the EU. And it includes raw materials and finished products. So you just need to make sure that the chemicals used to make the parts that you're buying in are not on the REACH prescribed list. And hence, all physical goods, once those chemicals are used to manufacture product, should be compliant with REACH. So it's the responsibility is placed upon the manufacturer to ensure that they're only buying parts that use acceptable chemicals. So if you're buying chemicals in to the EU for more than a ton a year, then you need to register with the European chemical agencies, and that's substance rather than mixtures or articles. So this is about chemicals, regardless of company size. And it requires every actor in the supply chain to communicate information on the safe use of chemicals. So we're all used to hazardous data sheets. So that everybody gets to know what it is that the chemical's got in it. So if you're a chemical importer, it's got that there's registration requirements. For everybody else, you just need to make sure that what you're buying doesn't have any of these prescribed and hazardous substances in it, and hence you're asking for data sheets, documentation exercise. UK REACH is exactly the same as the EU directive, so a bit like Roche, you can just read one as being applying to the other. So the last of these three environmental requirements is WEEE. So the WEEE directive provides the end of product life rules that keep hazardous materials from out of the environment. So we've got Roche, which is limiting hazardous chemicals in particular parts. We've got REACH, that's limiting, that's banning or controlling what chemicals are allowed to be used in production of equipment. So that's the input. What WEEE is looking at is what happens at the end of life. So not so much about protecting us while we're using the product, but what happens when we come to the end and we throw it away. So the statistics here, 13.5 million tons of electrical and electronic equipment put on the market each year, but only 4.9 million tons of e-waste is collected. So that's something like 8.5 million tons a year at the moment, and this is growing hugely, is ending up in the environment some way. And the number they give us is 11 kilograms per person in the EU. That's a lot of electronic waste on our behalf. So it requires collection and proper treatment of WEEE and sets targets for collection, recovery and recycling. You can't export it out of the EU to get around your obligations unless it's being disposed of in equivalent conditions as if you disposed it within the EU. So that's to stop it from dumping in developing countries, which is was happening in quite large order, apparently. So what's the scope of WEEE? All electrical and electronic equipment as defined by anything that uses electrical current or electromagnetic fields, which transfers, generates or measures these currents and fields, and designed for use with a voltage rating 1,000 volts or less or 1,500 volts. So effectively the same voltage limitations as the Radio Equipment Directive. There are definitive exclusions. Look at those exclusions, they're quite common. Space equipment, military equipment still. So common list of equipment that's excluded for this. But the last two are significant in that equipment specifically designed for the purposes of research and development, only available on a business-to-business basis, is excluded. And then medical devices and in vitro medical devices. Are also exempted from the rules of this. So what's your obligations under WEEE? You must first comply with the Roche directive. Well, that's important, that the input to your product needs to be correct. But you need to register with the responsible national authorities in each country where you distribute or sell the product, and that's where it becomes a pain. So you must have a mechanism for end of life in each of the countries that you sell into. You need to file a regular report on the amount of sold electrical equipment so they can track how much is being recollected, and then you must put the WEEE mark on. It isn't CE marking. So you CE mark for Roche, which you have to do anyway for WEEE, but then to show you considered end of life, you put the crossed out wheelie bin symbol to show that it's not to be thrown away, that there's a recycling. So your obligations: organize or finance collection, treatment, recycling, and recover the product. Join a scheme, or if you're a larger company, you'll make your own arrangements to get your product back. If you're a distributor, you have responsibilities as well. So you can provide a take-back service where you can return WEEE free of charge. Similar things go on with batteries as well. As with Roche and REACH, the UK regulations effectively transpose. So in summary, Roche, REACH and WEEE all share a similar objective: to protect us for human health and to protect the environment. Altogether, the rules cover the full product life cycle, from the base chemicals used to make product for the individual, which is REACH, for the components used within a Roche, and then WEEE, which is what you do with it at the end. It's really important that from manufacturers of product, you understand the obligations underneath each of these regulations. And certainly if you're part of a trade association, they'll be able to advise you more specifically on how you meet your obligations in your particular industrial sector. Different sectors have organized this in different ways. So you get a lot of advice from your trade associations on that. Okay, very brief summary on those environmental standards. And that just about brings us to the end of my presentations for today. So Barry, where we are on questions.
Yeah, we've had a couple of questions in from the earlier session, so I'm going to start with those. And just a reminder, if you have any other questions, pop them into the chat and we will get around to them. So the first one, it's quite a long question, so I'm going to read it out. And again, if you need me to repeat, just let me know. So it says, in the instance of a control panel builder designing and building panels for various OEM machine builders, are applicable standards as a panel designer are both the LVD and EMC directive. And the question is the risk assessment and compliance in relation to the machinery directive the responsibility of the OEM to dictate to us and we design to their risk assessment, even though our panel will eventually become part of the machine? It just seems a bit of a gray area, this person's asking.
The assessment of risks under the machinery safety regulations is the responsibility of the machinery manufacturer. They're making the assessment of the dangers with that machine, and then they need to pass that information on to the control panel manufacturer so that they can design the control panel to mitigate those risks at the request of the manufacturer. So the control panel manufacturer can't themselves know what the risks are with the machine because they're responsible for the panel. It may be that as part of the package the control panel manufacturer offers that they'll go and do that, but the responsibility is the machinery manufacturer, not the control panel. The control panel manufacturer is responsible for complying with the requirements placed upon them by the machine manufacturer as identified in the machinery risk assessment, and implement them in accordance with the control panel standards rules.
Super, thanks very much. So here's a shorter question. How do you overcome the CE plus CE equals CE problem, declaration of incorporation, and is this enough?
Declaration of incorporation is only for machinery. There's no declaration of incorporation for any other directive apart from the machinery directive. And a declaration of conformity under the incorporation under the machinery directive includes installation requirements to allow you to incorporate it in other machinery. So it's a very, very specific set of regulations. So if you receive a declaration of incorporation, you have enough information to add it to another machine to bring it into full CE compliance. But you can't just take a DFI for one machine and a DFI for another and join them together and not make an overall assessment of the final product. So even with declarations of incorporation, CE plus CE doesn't apply. And certainly on the other regulations, it doesn't. CE is specific to the particular product type. And if you combine CE marked components under any of the directives with any other CE component, you have to do a risk assessment of the implications of joining them together and to make sure there are no gaps before you put your own CE. There's only one CE mark on a machine or on a panel or on electrical equipment. That's the CE put on by the end manufacturer, who has to take into account what other people have done on the way. They take the final responsibility.
Super, we have one more question, and it is, as someone who checks installed equipment for compliance with relevant standards, can I take CE marking as compliance with all relevant standards for that item, or should I be checking compliance with BSEN or IEC numbers instead?
Depends what you're being asked to do. Just because, as I said at the start, CE stands for caveat emptor, let the buyer beware. The CE mark regime, so the declaration of conformity, contains details of standards, but I think it depends on what you're inspecting it for. If you're saying, is this machine suitable for use, then it has to be minimum CE mark, but then everything does. If you're going to be more diligent, and you might then say, well, I should be checking against the standards because that's more specific to my product. But as a machinery inspector, the CE mark isn't intended for you. It's not the intent for that. It's a manufacturer's declaration. And customs, and basically the people who've got access to the technical file. If you haven't got access to the technical file, the CE mark is nigh on meaningless. So you probably should be thinking about compliance with the standard. When you ask for compliance of component parts, they'll almost certainly give you the CE declaration of conformity with standards listed on it. So it's part of the tool, but CE mark itself is not, you can't sell it. If it hasn't got a CE mark, it's illegal to sell it and illegal to use it by and large. So it doesn't tell you anything.
And actually the delegate who put the question has just provided a little bit of follow-up. So it asks, is certification regulated? Are there checks in place to ensure products actually meet regulations and directives?
If it's CE marked, unless it's subject to notified body rules, then no, there's no third-party requirement. It's the manufacturer's declaration that they believe that they meet the requirements. So there's no check on a CE mark per se, with the exception, as I said, if it's been subject to notified body approval, and that would be written on the declaration of conformity because you have to name the notified body on it, then it would have been subject to third-party testing. But beyond that, CE doesn't mean that. Manufacturer may have had third-party assessment done, and if you ask them, they might provide you a third-party certificate to standards to show what they've done. But the CE mark doesn't mean that it has, and most CE mark products haven't.
And then, sort of again, thanks, Hugh. Hugh has submitted just one final point on this, and it asks, are there consequences for false declaration of conformity?
Yeah, if you make a false declaration of conformity and health and safety or customs pick you up on it, now you can be fined. It used to be £1,000 per offence. It's probably more than that now. But it is an offence to make a false declaration of conformity or falsely CE mark a product in its own right. It's a Health and Safety at Work Act. This will be that in the UK, it would be the Health and Safety Executive. Almost certainly would prosecute you for industrial product, and then trading standards for consumer products. But yes, it is an offence to falsify or a CE mark or a declaration of conformity.
Super, thank you. Another question, is EMC/EMI testing, is it mandatory for construction equipment which is operating at remote areas?
There's no exemption for remote areas, as far as I'm aware. If it's a fixed installation, then CE mark rules don't apply. But if it's not a fixed installation, then no, I think it still applies. I don't think there's any particular exemption for that. It's probably down to a definition of remote areas, isn't it? Really. I suppose if you're operating in a quarry in the middle of nowhere, then perhaps. But it's got to get there, and the machine may be being used in other places on the way. So I'm not aware of any specific exemptions for it. But that would be part of your risk assessment. When you're doing your risk assessment at the start, when you're considering what EMC measures you need to have in place, the location is really important. So you can you build your rationale out of the file, check the rules. When you've said there's the risk is low because of this, then I can perhaps justify that. However, there are a few places where you're in a completely EMC benign environment, where there are no other things to interfere and no other things that are going to be interfered with by a machine. These days, we've got the mobile communications, mobile phones, computers are around everywhere. So it's much less likely to find that sort of remote environment. But risk assessment is where you make that decision.
Simon, that is all the questions we've had in. You've done an awful lot of talking this morning, so thank you very much. I really appreciate it. And thanks everyone for putting questions in. That made for very interesting last part of the session. I'm going to hand over now to Colin Graham again, who's just going to wrap up before we leave. Over to you, Colin.
Yeah, thanks, Barry. So just to finish off, I'd again like to thank Simon for his very excellent presentation and also for fielding all the questions, which are great to hear, and some excellent questions and very varied question material today. So thanks very much to Simon, also to Barry from Eventful for making sure that everything ran smoothly and for lining up the questions and posing them. But most of all, thanks to everyone who attended this morning from wherever you're listening. We hope you found it worthwhile and a reasonable introduction to this. And as we emphasized earlier, you will be getting the slides and access to the video of today's or this morning's session before long when that's been put together. Hopefully some of you will be able to join us next Thursday for the CE Mechanical Machinery Directive webinar and the week after the Global Technical Compliance webinar event where Simon will return. So if you or if any of your colleagues are interested in attending these, they are free and you can register to attend at investni.com/events. That's all for this morning, and that concludes today's webinar.